Thank you everyone for being here for another wonderful day with the Humanist Association of San Diego. Each week, when we have a discussion or a speaker, I like to say what the theme of the day is. Because we're not just a group to feature interesting speakers or have a robust discussion. We're a strong community organization that's deeply involved with the articulation and promotion of humanist values. The religious right who claim a monopoly on values strictly do not have a monopoly on values. A lot of the best, if not the best, ethics and values come from a naturalistic base. Essentially, reciprocity, fairness, compassion, they're more than just the language of humanity. I would go so far to say, looking at our closest relatives and then extending out beyond with dolphins, corvids, pachyderms, etc., they're the language of mammal. We speak the language of mammal, and we promote great values that aren't just relevant for humanists, but relevant for everyone. They create a level playing field where we can all operate, cooperate, and thrive together. And the value that I would like us to meditate on today is interdependence. Just this last month in April, about a month before today, the Arkansas State House passed a bill 72-21 to include creationism in the science classroom. We're talking about evolution today, and we're talking about myths associated with evolution. This isn't something that we can look back and say the religious right promoted it and it's kind of waned. This isn't something we can look at and say COVID has given us more important things to do. Arkansas, which is one of the worst states for COVID response, the state legislature took its time, its valuable time when it could have been working on saving lives, to promote creationism in the science classroom 72-21. It failed in committee in the state Senate, fortunately, but people are so committed to this idea of promoting particular myths at a time when we don't have time for this, that this is something that's critically important for us to focus on today. These issues have given us both busy work and a flying spaghetti.
Yeah.
And today is about interdependence. Promoting creationism in the science classroom is not about interdependence, it's about division and supremacy. But today is about interdependence. We're going to focus on interdependence. Today is also Mother's Day. We think of our mothers, we think of where we came from, we think of heritability. We think of heritability not just from our mothers, grandmothers, or 23andMe or Ancestry.com, where we see I'm 72% Irish, 18% Scandinavian, 5% Sub-Saharan African, We think further beyond that to the broader origins of life on Earth. And we see that through this commonly used phrase, ontogeny recapitulates phylogeny, that we're all connected. That was Darwin's dangerous idea, that we are all connected. Yet there are ideological factions in this country, like I mentioned in Arkansas, that use the wheels of government to shy away from that. In 2019, according to the Pew Research Center, only 81% of US adults believed in evolution. 38% of white evangelical Protestants say that human beings have always existed in their current form. Out of the members of the American Association for the Advancement of the Sciences, 98% of scientists believe in evolution, and yet 76% of US adults believe that all biologists believe this. That's 1/4 of Americans who don't even believe that biologists believe in evolution. Denying evolution denies our connection to one another and our connection to all other animals and our actual place in the world around us. And it's not just a denial of evolution, it's also the directed ideological preferences that want to disparage naturalists like Charles Darwin that also serve as a problem. A pastor local to Huntington Beach, Ray Comfort, in commemoration of the 150th anniversary of the publication of Origin of Species, which is in the public domain, so he was able to put out his own copy of it, wrote a sizable prologue to Origin of Species, in which he asserted essentially that Charles Darwin was one of the fathers of eugenics. And people read this, and people believe this, and people deny the fact that we evolved along a gradual process. And they also have evidence to the contrary right now. For example, we have a virus that is mutating in response to our efforts to stop it. We're seeing quick changes so a small organism can have a successful reproduction to propagate. This is disturbing, it's saddening, but there is hope. And while some of us may have misconceptions about evolution, we have important minds. We have brilliant speakers. We have wonderful educators who can help show us the way. And today we have one such person. We have Dr. Eugenie Scott. Dr. Scott has a whole host of awards, Lifetime Achievement Awards from the American Humanist Association, for the Centers for Inquiry, and also the Public Welfare Medal from the National Academy of the Sciences. And this year it has gone to Anthony Fauci. She's the former director of the National Center for Science Education, which it advocates the teaching of science as a way of knowledge, the teaching of evolution, the teaching of climate change. She's an author, a teacher, a professor, and an advocate for secularism, science, and reason. She is the author of Evolution versus Creationism, an introduction, and with the co-editor being Glenn Branch of Not in Our Classrooms, Why Intelligent Design is Wrong for Our Schools. She's the recipient of numerous awards from scientists and educators and has been awarded 10 honorary degrees. She even has an asteroid named after her. 249540 Eugenie Scott was named for her in 2014. I can't sing her praises enough. We are fortunate to have Dr. Eugenie Scott here today to talk to us about misconceptions in evolution. Dr. Scott, let's all give Dr. Scott a warm San Diego welcome, and thank you for being here today.
Thank you so much. That was a very welcoming introduction indeed. Now I'm told that I can share the screen and we can, there we go, we can get on with it. All right. So a little bit of background on me. I used to teach evolution as a biological anthropologist. And then when I became director of NCSC, I, of course, as Jason suggested, hang on, I'm just getting rid of some of the superfluous material here. There we go. At NCSC, I defended the teaching of evolution. So between students and the general public, I encountered a lot of misunderstanding of what evolution is actually about. So what do people get wrong about evolution? Come on, you can do this. All right, there we go. Now, a place where you can learn a lot about people's misunderstandings about evolution is AM talk radio. A lot of these morning shows have their own frustrations, but the call-in shows are kind of an interesting finger on the pulse of the general public. And the question that I got asked most frequently was, why is this problem happening here in the United States? How come other countries aren't as goofy as we are? What's going on here? The second most common question that I get asked was, if man evolved from monkeys, why are there still monkeys? Thank you, Jason. Hope you don't mind being part of my talk. Now, there's a whole bunch of things that are wrong with this statement, including the very obvious one that it would be very difficult for males to evolve all by themselves. So, leaving out the gender-specific language here. And, even if you know that chimpanzees are more closely related to humans than monkeys are, if people evolve from chimps, why are there still chimps, is not really much of an improvement. It's, and quite honestly, not that many people know the difference between chimps and monkeys anyway. But think for a moment, what must be going on in a person's mind when they say something like, if people evolved from monkeys, why are there still monkeys? I think they must have a concept of evolution sort of similar to that of human growth and development. Like, here's a bunch of babies. Come back 5 years from now, and here's a bunch of kids. If children comes from babies, why are there still babies? And in that context, that's not that crazy an idea, but that's not evolution. That definitely is not evolution. Evolution is not a linear procession from one form to another. There was an Iowa legislator a number of years ago, back in the 80s, and every year he'd get up and he'd introduce some legislation that was against the teaching of evolution or for the teaching of creationism. And he'd always say, I have been a farmer for 42 years. I have never seen a chicken turn into a cow. Gotta say, he's got a point there. Of course, evolution is not an individual phenomenon. Yes, indeed, chickens do not turn into cows. It's a populational phenomenon. It's a group of organisms that either do or do not evolve. It's not an individual kind of thing. But notwithstanding, it's a populational phenomenon, and it's not a linear progression from one form to another. There's a strong implication of progress underlying this conception of evolution. A baby progresses to a child. A monkey progresses to a human. And the idea of progress is pretty well baked into Western culture in a lot of ways. You've all seen this picture. Most likely you've seen parodies of this picture, because there's a zillion parodies out there and they're all pretty hilarious, most of them. The upper diagram, by the way, is the original of all those parodies. It was a Time Life Early Man book from 1965, within living memory of some of us. It was edited actually by Clark Howell, who was a University of California, Berkeley anthropologist, died a number of years ago. Very brilliant scientist. But nonetheless, this idea of evolution as progressive is very widely held. I think this idea of progress, as I say, it goes back in Western culture a pretty long distance. And the origin of it is really the great chain of being, which was originally an Aristotelian idea, but Christians picked it up in the Middle Ages and made some modifications in it. The great chain of being, or the ladder of life, begins with inanimate nature and works its way through animate nature, finally getting to the sublime. All of nature can be ranked in a series of either complexity, sometimes purity, closeness to God. There are various ways that you can rank these aspects of the natural world. Now, humans, of course, are very close to the top. As it says in Psalm 8, "What is man that thou art mindful of him? For thou hast made him a little lower than the angels." And Ralph Waldo Emerson, I really can talk. Ralph Waldo Emerson's mid-1800s poem, Mayday, reflects upon this idea. The subtle chain of countless rings, the next unto the farthest brings. And striving to be men, the worm mounts through all the spires of form. So the worm mounts through all the spires of form, eventually ending up with, you guessed it, humankind. But the great chain of being is ultimately a creationist perspective, with God purposefully creating each of these rings separately. The idea of progress is inherent in the sequence, but it's definitely not an evolutionary sequence. So if your idea of evolution tracks the great chain of being, then the idea that if people evolve from monkeys, why are there still monkeys makes sense. It's impossible to move from one rung to the next because it's a creationist perspective ultimately. But evolution is not about progress. It isn't about ladders. Evolution is about trees, and it's about the branching and splitting of lineages through time. Darwin himself conceived of evolution as being tree-like. This is a diagram from Darwin's Bee Notebook from 1837, before he wrote On the Origin of Species, after he came back from the voyage on the Beagle. And yes, this was one of the 2 Cambridge University Darwin collection books that has disappeared and is feared to be stolen. It's very upsetting, but nonetheless, it's all been copied. It's all online, so the information isn't lost. But the actual notebook would be pretty awful if that was lost forever. Nonetheless, Darwin, this Bee Notebook diagram is thought to be the very first representation of evolution as a branching tree. It was the inspiration for the logo of the National Center for Science Education, of course. And actually, if you look at Darwin's best known, but not his only book, his best known book On the Origin of Species, there's only one illustration in the whole book, and it is of a branching tree. So Darwin really felt strongly that trees were central to his big idea of common ancestry. So in order to understand why, if man evolved from monkeys, why are there still monkeys, is so very wrong, let's do a little bit of evolution 101. Now, evolution has 3 basic components. The big idea of evolution is the idea of common ancestry, that living things have descended with modification from common ancestors. The second big idea of evolution is the mechanisms or factors affecting bringing about evolution, the processes of evolution, natural selection being the most important, but there are plenty of other mechanisms of evolution as well. Evolution is not only natural selection. The third component of evolution is the patterns of evolution. How does the tree of life branch through time? What forms are related to other forms, and how closely or how distantly? Now, these 3 components are actually conceptually all independent. And there's actually a historical component to this as well. You doubtless know who Thomas Henry Huxley was, Darwin's bulldog, as he's sometimes called. Huxley, of course, really went to bat for the somewhat reclusive Darwin and Darwin's ideas. Huxley was totally on board with the big idea. He was totally on board with common ancestor, and that's where he really came out swinging against Bishop Wilberforce and everybody else. He wasn't all that nuts about natural selection, which disappointed Darwin, because Darwin really thought natural selection was his big contribution to the idea. But a lot of scientists at the time actually were not really convinced about the natural selection mechanism. So you certainly can accept the big idea while not accepting natural selection. By the way, creationists reverse that. They're totally on board with natural selection. You cannot deny natural selection. There's plenty of evidence of it all around, but they reject the big idea, which is kind of an amusing historical fact here. But similarly, patterns of evolution are also independent from the process or the big idea. Bears and dogs are closely related to each other, but the inferences that we use to come to that conclusion that bears and dogs are related are different from the inferences that we use to, sorry, I said that wrong. The data that we use to infer that bears and dogs are closely related to each other are different from the data that we use to infer that living things have common ancestors. And similarly, if bears and dogs are more closely related to each other than they are to cats or cetaceans or whatever, it doesn't matter whether their evolution was guided by natural selection or if other mechanisms were involved. These 3 components are independent. And it's kind of useful to know that, because The way creationists look at evolution is they look at this as a complete package. So that if scientists are arguing about a pattern issue, about bears and dogs being related, or whales and land animals, and they haven't come to consensus on some aspect of evolution, aha, that means the big idea of evolution is false, if you're a creationist. Or if scientists are arguing about how powerful is the natural selection mechanism for producing something like body plans, say, aha, scientists are arguing about evolution, therefore common ancestry didn't happen. So it's nice to be able to and it's correct, to conceptualize these three aspects of evolution as being independent. So let's talk in more detail about the big idea of evolution, because here's where there are a lot of misconceptions, like evolution being this linear progress towards some end. Now, descent with modification is kind of a 19th century phrase, but it's something that everybody listening to this video is very familiar with, even if you haven't thought about it, because like me, you have descended with modification from common ancestors. Here's a family tree of some of my ancestors, some of my relatives. Now, Grandpa Roy is the father of Dad and also of my father's brother, Uncle John. Sue is my sister because she and I share Dad in common, and Mary is our cousin because she is the daughter of our uncle, and all three of us share Grandpa Roy in common. Now, everybody understands this. Family trees are very familiar to everybody. A family tree is descent with modification, obviously. Sue and I descended from our father, but we're not identical to each other and we're not identical to him. We have descended with modification from our common ancestor, our father. Yet Sue and I look more like each other than we look like cousin Mary, because Sue and I shared a common ancestor with Dad more recently than we shared a common ancestor with Mary, with Grandpa Roy. Sue and I share half our genes, and we only share a quarter of our genes with Mary. Basic genetics. And actually, basic genetics is at the heart of our understanding of evolution these days. Same thing, same general principle works across the board with groups of organisms and evolution. The more recently two groups shared a common ancestor, the more similar are the organisms. So bears and dogs look more like one another than they look like cats, because bears and dogs shared a common caniform ancestor with one another more recently than they shared a common carnivore ancestor with the cat group. And Cebus and howler monkeys look more like each other than they look like apes, because they shared a common ceboid ancestor with one another more recently than they shared a common primate ancestor with the apes. But bears and monkeys are more like each other than they are like, say, salamanders or crocodiles, because they shared a common mammal ancestor with each other more recently than they shared a common vertebrate ancestor with the salamanders. This is the big idea of evolution, common ancestry, the branching and splitting of lineages over time. The big idea of evolution is trees, not ladders. Now, I drew my family tree to look like a tree, but I could also draw it another way. We can redraw my family tree the way an evolutionary biologist would look at it, showing Sue and I descending from our common ancestor Dad, and the two of us descending with cousin Mary from our common ancestor Grandpa Roy. Now, obviously, I've left out Uncle John and a whole lot of other relatives, but that's okay. This is just a schematic anyway. So, plenty of cousins have been left off the list, but the important people are being shown here. This is very similar to the relationship among African apes, monkeys, and humans. Humans and apes shared a common ancestor, which gave rise to modern African apes and us. The human ape group shared a common ancestor with monkeys. And obviously this tree is simplified too. There's a lot of relatives left off, just like with my family tree. Just between the common ancestor and humans, there's lots and lots and lots of cousins in there. We don't have quite as good a fossil record, unfortunately, between the common ancestor and African apes, which is, interesting, but a different kind of problem. Now let's go back to our original misconception. If humans evolved from monkeys, why are there still monkeys? Now, this diagram is pretty much what the conception is, that assuming certain amount of sophistication about apes, that monkeys evolved into apes, evolved into humans. That's like asking, if you evolved from your cousin, why is your cousin still here? The answer obviously is, I didn't evolve from my cousin or my sibling, and people didn't evolve from apes. We share a common ancestor with apes, and you share a common ancestor with your siblings or cousins. Evolution is all about trees, all about branching and splitting lineages, and common ancestry. It's not about ladders, and it's definitely not about humans came from monkeys. Now, there are plenty of other misconceptions associated with the big idea of common ancestry, and I can't cover many of them, but I do want to talk about a very important one. Like I say, one of the best ways of learning about what the public thinks is with radio call-in shows. And in my career at NCSC, I noticed fairly quickly that whenever I was on a radio show in a city that had whenever I was doing a radio show of a station that had a large African-American listenership, like Oakland or Detroit or Washington, D.C., Chicago, somebody would invariably call up with the claim that Darwin was a racist. Not just our friend Ray Comfort, as our friend Mr. Fry pointed out to us, right? The ranking of things like the Great Chain of Being is a very hard idea to get over. And similarly, the ranking of races within a species is the same principle. And from the get-go, it's not an evolutionary perspective. The ranking of races became a thing, if you will, after the European voyages of discovery in the 1500s and thrived thereafter. In the 1700s and 1800s were a period of the flourishing of evolution, of European colonialism, which required justification of the exploitation of the, quote, savages and their resources, which, of course, is what colonialism is about, it's resources. Racial superiority with Europeans on top was an easy sell under those circumstances. But remember that the ranking of races doesn't depend on, nor did it begin with evolution. Plenty of people who know nothing of evolution, nonetheless, are racists. Science is a very powerful cultural institution, and plenty of ideologues will seize upon science to support their narrative. The two major explanations of the origin of races before Darwin are polygenism, that races have separate origins, and monogenism, which is the idea that races are all descended from one group. Now, biblical literalists are the ultimate monogenists. Adam and Eve are the ancestors of us all. Ken Ham of Answers in Genesis, the largest creationist group in the United States today, he gets the science wrong just about every time, but at least he gets this part right. We are all brothers. Some Christians, however, did hold to a polygenic origin of races, such as the pre-Adamite view. Now, if you read Genesis in one way, you might infer that there were two creations, one in the first verse of Genesis and one in the second. And it was people who believed in this two creations of Genesis that believed there was a separate creation before the Adam and Eve creation, which was the second creation. The first creation was a pre-Adamite creation. And those pre-Adamites were thought by some to be the ancestors of all of the non-European, non-African people that were discovered by Europeans during the Age of Discovery. You've never heard of Polynesians before. You've never heard of Australian Aborigines. There were a lot of people that were encountered that just weren't in the Bible, and that Europeans didn't have any experience with. Pardon me. Scientists in Darwin's time came down on both sides. Cuvier, for example, was a polygenist. Polygenism is ultimately a static view. God created the races separately, and they were distinct and unchanging. Darwin himself strongly promoted the view that there were too many similarities among modern races for them to have had a separate origin. Darwin was, of course, a monogenist. And to Darwin, the science argued for a common humanity. Darwin is sometimes personally accused of being a racist and a sexist. James Moore and Adrian Desmond's book, Darwin's Sacred Cause, claims that the very long-standing abolitionist views of Darwin and the Wedgwoods motivated him to develop this particular view of evolution. Now, Darwin was a person of his time, as we are people of our time. He believed in the superiority of Europeans, but it was not innate. He got into trouble with Captain Fitzroy on the Beagle regarding the intelligence of individual Africans, Polynesians, and so forth. There was a hierarchy of civilizations, according to Darwin, but not because of, quote, race. It was a result of history and culture. Now, it is not correct to make Darwin a 20th or 21st century liberal, but it is also not correct to demonize him as a racist. He was a person of his time. He had ideas that were typical of many people of his time, but scientifically, his views on race were surprisingly modern. Darwin defended the idea that races were mere variants of the species Homo sapiens. All people, including Englishmen, came from savage origins, that way back in the past, even the English and other Europeans who were at the time considered superior, of course, did come from ancestors who, squatted around campfires, as they would say back in the day. Different races, according to Darwin, and actually according to modern science as well, have much more in common than people during Darwin's time believed. This summary, by the way, comes from a quite wonderful website called skepticalscience.com. These were all points I was going to make, and then by golly, I just ran across them on Skeptical Science, so I thought, fine, I'll use their outline, such a deal. Skeptical Science usually is concerned with the climate change debate, but they've got generally good stuff on it. Check it out. All right. The mental capabilities of all races are virtually the same, and there is greater variation within races than between races. Another point of view that Darwin held, which was surprisingly modern. Different races of people can interbreed, and there is no concern for ill effects. This is interesting also because Darwin was personally very concerned about marrying his cousin. And they had 10 children. They had a big family. 7 of them survived to adulthood. But Darwin knew nothing about genetics. Nobody did back in the early 1800s and mid 1800s, which is when he was most active. But he knew from looking at domesticated animals that too close line breeding resulted in defective offspring. And he was, concerned about whether he and Emma, because they were first cousins, might have children that were defective in some fashion. But in terms of populational groups, in terms of Africans or Asians or Europeans or whatever, this is not a problem. This is not a problem. And culture, not biology, accounts for the greatest differences between the races. He also recognized that races aren't distinct, but rather they blend together, which is an insight that certainly today's white nationalists don't appreciate at all. And the remarkable thing is that Darwin held all these views without knowing anything about genetics. Today, with an understanding of population structure as guided by modern genetic understanding, racism becomes even less supportable by evolution. This is a topic that I've addressed in other talks, and I'm not really going to take a lot of time for it here, but the takeaway is that races are open genetic systems. And when you have an open genetic system, you cannot have stability, continuity, or purity, all of which are central to racist views and which therefore are not supported by evolution. And let me at least briefly explain. These are species. Species are all the biological entities that can interbreed with one another. Species cannot interbreed with other species. Where you get things like mules or tiglons, which are tiger-lion crosses, it's a result of incomplete speciation. Evolution is all about genes and passing on information to future generations. There are lots of good species. Cats don't interbreed with dogs. And as sorry as I am to say it, there is no crocoduck. It would be great, but there you have it. And of course, scientists will debate the definition of species. For our purposes in a general talk. We'll just go with the traditional definition. Now let's look within a species. Now, unless a species is really small in number, and in the tropics, you can find species of insects that have a range literally of a couple of trees, but most species are not in that situation. Most species consist of local breeding populations known as demes. The large hearts, because after all, we're talking about breeding, aren't we? The large hearts on this page represent demes, and the small hearts represent individuals within a deme. By definition, individuals within a local breeding group can and do interbreed. And because demes are open genetic systems, individuals from one deme can breed with and exchange genes with members of other demes. Anything below the level of a species is an open genetic system, and genes can and do swap around. All right, now we're going to shift back to that previous slide where we're talking about species again, that big blue circle. Notice, and here the small hearts are going to be demes, all right, local interbreeding groups. Now, demes within a geographic region are more likely to exchange genes with other demes within that region, just as a matter of propinquity or probability. As a result, sometimes, not always, demes will share similarities in a geographic area. This is what biologists call a subspecies or race. North American peregrine falcons are divided into 3 subspecies. They live in different geographic areas. They differ phenotypically. They can interbreed, but they don't usually because they're geographically separated and don't often come into contact with one another. In this diagram, we're back to species again. The little hearts are demes. The big ovals are collections of demes, subspecies within a species, like peregrines in British Columbia or peregrines in northern Canada. Now, demes within a common geographic range are more likely to exchange genes, again, just because of propinquity. But because subspecies are open genetic systems, members of demes from different subspecies can interbreed and share genes, and do. It's more likely that demes on the margins of the ranges of a subspecies will interbreed because subspecies have this geographical component to them. Peregrine subspecies in Alaska and northern Canada, where that box is up at the top, pardon me, that overlap are more likely to interbreed with one another than they are with peregrines in British Columbia or coastal California. Note also that not all demes can be placed into a subspecies. Subspecies are rather arbitrary geographical groupings, and not all demes show the geographical and morphological similarities that we associate with a subspecies. Anything below the level of a species is an open genetic group. So what does this mean for the idea of race? Well, races, because they are the product of open genetic systems, are not discrete bounded entities. They are not stable through time. They are not permanent. They are not pure. They are not rankable. If you understand biology, population structure, and evolution, race, as most people think of them, does not exist. If you, pardon me, which is not to say that there is no biological differences within the human species, nor between individuals, or even between some geographical groups. If I parachute into Nairobi, I'll know I have not parachuted into Helsinki. But that doesn't mean that races in most people's concept of race, which involves these characteristics, is a real thing. They are not. The big idea of evolution, common ancestry, thus does not make a very good source for racism, where the ranking and the great chain of being stuff isn't part of the theory. And the genetic populational foundation for evolution further destroys racism. But the mechanisms or factors that bring about evolution, the processes, that pink box there, those have also also been accused of supporting racism. And natural selection, of course, is the most important of them, has been the one seized upon by racists to support their views. Plus, there's a lot of misunderstandings about natural selection, some of which I'll be touching upon. So let's do a little bit more Evolution 101. Now, it's obvious that creatures are fitted to their environment. Antelopes, bears, and hawks all do different things for a living, and they all have different morphological features. You would not expect to find the teeth of a bear in a hawk. You don't find wings on antelopes. Before Darwin, the prevailing explanation for how animals were suited to their environment, the gazelle has long legs to escape prey, etc. This was the result of special creation by God. God specially created the long tarsal bones of gazelles so that they could escape prey. And I guess God also created the very sharp teeth of the cheetah so that it could eat gazelles. But that's the theodicy problem for you. Here you go. The reason that natural selection was such a radical idea when Darwin came up with it is that he was explaining these kinds of adaptations as being the result of a natural cause rather than special creation by God. And so to some people, that meant, natural selection was an atheistic point of view. God had less to do. Doesn't have to be that way, but that's another discussion. But that is a major reason why natural selection wasn't accepted by many people of Darwin's day, although the scientific evidence for it is very strong. Others opposed natural selection, like Thomas Henry Huxley, mostly because back in the mid-1800s, no one knew how heredity works. There wasn't a science of genetics. And there was no good understanding of how variation could be generated every generation. And every generation, there had to be variation, otherwise natural selection can't work. And of course, that problem was solved in the 20th century with Mendelian genetics. And of course, we've gone beyond Mendelian genetics. Let's take a look at natural selection. The most important part of natural selection is reproduction, because genetics and evolution is all about getting descendants, getting characteristics, getting populations into the next generation. But it's differential reproduction in the sense that not all characteristics are passed on to the same degree. Some are passed on more than others. Some aren't passed on at all if they're lethal. So differential reproduction is really important. But natural selection specifically is adaptive differential reproduction. It's the idea that the characteristics that are differentially reproduced into the next generation are so because they have a value to the population in which you find them. Could be a negative value, could be a positive value. A classic example is the peppered moth and several other moth species that come in more than two colors or varieties. You're all probably familiar with this example. It's one from your high school science class. Dark and light moths show up quite differently depending on what color background they're resting on. It's easier for birds to see a dark moth on a light background, a light moth on a dark background, and thus pick them off. Now, the British have been collecting moths for hundreds of years, and collections of Lepidopterus showed that moths before 1848 were light colored. The first dark moth was found in 1848. And it was likely a very rare mutation. 47 years later, 98% of moths in British collections were dark moths. And this, of course, is a result of the Industrial Revolution. Coal burning, coal burned during the Industrial Revolution darkened the substrata on which moths rested, made it easier for birds to pick off the ones that contrasted in background, and the dark moths were therefore selected for. With cleaner fuels in the 20th century, there was a reverse of that. And now the most common moth in Great Britain is light-colored moths because of the cleaning up of the substratum. The original work was done by Kettlewell in Great Britain, but there was a parallel rise and fall of dark and light-colored moths in the United States and Germany for the same reason. A recent study by Barrett and colleagues showed natural selection on deer mice, Pyramyscus, in case you want to know the genus, in Nebraska based upon the coat color of the mice and the color of the soil where they lived. Now, not all deer mice are the same. Aren't they cute? They're really adorable, aren't they? But they're not all the same color. Some are genetically darker than others. I wonder if they're all this pudgy. Those are really quite robust little mice. At any rate, the hypothesis of the investigators was that the owls, which is the major predator of mice, would be better able to see mice that contrasted against their background. So they had two adjacent plots, one in the sandhill regions of Nebraska and another on just regular dark soil. They built 6 enclosures, 50 meters square, 3 in each locality. 3 in the sands, 3 in the dark. Here's a pickup truck for scale. These are really big pens. What they do is they went into the pens, they took out all of the mice that were there, they took out all the snakes, which was probably a pretty good idea. And then they collected mice, measured them, took genetic samples and chipped them, and then put them back into these pens in appropriate ratios, and then sampled the mice at intervals for a year. They found that just as with peppered moths, the frequency of mice with coats that contrasted with the background reduced in number compared to mice that matched the background. The blue bars show the distribution of colors at the beginning of the study, and you see that it's pretty much a normal distribution in both the light sites and the dark sites. And then the red bars show the distribution at the end, and you can see that there's a shift in mean frequency toward the lighter side in the light sites, and a shift toward the darker colored mice in the darker sites, which is kind of cool. So schematically, remember that natural selection is something that happens to a population, not to an individual. We're talking about populations of deer mice, not individuals. Any population consists of a number of individuals. These individuals are not identical. They vary in various traits. As you see, some mice had darker coats, some had lighter coats. Coat color is under genetic control. Every generation, variation in coat color is produced by a number of genetic factors, particularly recombination, actually. In this experiment, the environment was changed. Mice were moved into different locations, excuse me, and some of them were at a disadvantage and some were at an advantage because of their genes. Change occurred in these populations because of the adaptive advantage, the differential reproduction of traits in a particular environment. The takeaway here is the adaptive value of genes depends on the environment. A gene may or may not be adaptive depending on environmental circumstances. There's a lot of misconceptions about natural selection, one of which is that natural selection points to a particular end. Natural selection is specific to time and place. It operates only on populations of a species then and now, so to speak, or there and then. It's not a process that points to a particular end, nor can it anticipate what will come in the future. Pine beetles are increasing in the Western US as a result of climate change. They like to be warm, and as it gets warmer, they hatch earlier, attack the trees earlier, attack for longer, and they end only with freezing temperatures, which of course is later in the year because of warming. Now, natural selection is operated in both beetles and trees for millennia. Well, no, millions of years probably. Natural selection thousands of years ago can't prepare a tree to fend off beetles when it's weakened by climate change today. One of the defenses that trees have against beetles, for example, is they produce resin. Well, if there is water shortage, the tree can't produce as much resin. And of course, one of the problems with warming is drought. Selection for trees thousands or longer years ago for revving up the arms race against beetles at a particular time of year is also not going to work now if the beetles are attacking earlier because of warming. Trees are going to need to adapt, or we'll find that they don't adapt and we'll lose even more trees. to pine needles now, in this time and place. Alas, natural selection does not work ahead of time. A big misconception about evolution is that it results in perfection, and it does not. Species are not perfectly adapted to their environments. You know, there's the phrase that you've all heard, survival of the fittest. I want you to think of natural selection as survival of the fit enough. Think about that. Our little mice friends. The chart of the mice in the contrasting soil environments is a good example of this. In the red bars, notice that there are still some mice on the, quote, wrong side of the direction of selection. This is due to basic genetic recombination. But it isn't surprising when you consider the genetic underpinnings of natural selection. Basically, not just the organisms that have the best combination of features for the particular environment at that particular time pass on their genes, but all of the organisms that have enough of what's needed to survive and reproduce then and there. So there's always a tail in the wrong direction, shall we say. Evolution doesn't result in perfectly adapted species. It's survival, actually reproduction, of the fit enough. Finally, neither evolution nor natural selection are the result of chance. There are some probabilistic elements in the production of genetic variation on which natural selection works, but adaptation of organisms to their way of life is not a chance process, but rather the result of the advantage that traits provide in an environment, the adaptive differential reproduction. I started this discussion of natural selection and mechanisms of evolution because natural selection has been used to promote racism. The idea is that natural selection operating on different races would produce superior and inferior races. I came across this diagram when I was looking for illustrations, and it is just so Baroque, I just had to share it with you. It's just quite grand. This is an idea held by many Victorians, of course, during the 19th century, when the sun never set on the British Empire. But natural selection can be used to argue against racism as well. Two theoretical perspectives. One is that in a wide-ranging species, natural selection is going to operate differently on populations that are in very different environments. And we see this in many species. This is a chart of wolves, by the way. Wolves, rats, mountain lions, turkeys, lots of animals vary by geography. They differ in coat color and size, other morphological traits. So why shouldn't we expect natural selection to be operating differently on humans in different environments? The argument continues that therefore races of humans being established in different environments are selected for differently. Broad noses are selected for in hot, moist environments, narrow noses in cold, dry ones. More linear builds are found in hot environments because they dissipate heat and so forth. And indeed, features like skin color, hair texture, body morphology, facial features, and so forth may be selected for differently. And thus far, it's not objectionable nor doesn't support racism either. The question is whether, and this is the big question, whether we should expect that central nervous system differences will also be selected differently. The claim is made that we should not be surprised if some groups of humans are more advanced, or smarter, or more creative, or fill in the blank with some positive adjective. Now, the other theoretical perspective is also based on evolution and natural selection. Yeah, natural selection may act upon populations in a geographical region. Giraffes, for example, have a number of subspecies, and there are phenotypic differences among them. But all giraffes have long necks and long legs and teeth suitable for browsing, because browsing from treetops is how a giraffe makes its living. So even if natural selection might operate on regional variations of a species for things like shape and size, characteristics of the species that are required for survival are going to be canalized or genetically restricted to reduce variation. Canalization is a genetic term. The human species doesn't depend on long necks or browsing dentition. Actually, our bodies are pretty generalized, other than specializations for bipedalism. Our major adaptation to the many environments we occupy is our tool-making capability, our superior communication ability, and our ability to change our environments. In other words, our major adaptation is our large brains, a function of our central nervous system. And of course, all groups of humans are bipedal. They have large brains and can communicate through phonemic symbolic language. And just as bipedalism is canalized, try surviving by walking on all fours. The anatomy just doesn't work. So also our brain-based adaptations will also be canalized. All groups of human beings have the mental ability to solve problems and adapt to the environments in which they live through appropriate technology. An example, the traditional Inuit devised a technology that was admirably suited to the Arctic conditions in which they lived. If they hadn't, there would be no Inuit, right? Natural selection operates on cultures. The Norwegian Roald Amundsen beat the Englishman Robert Scott to the South Pole, partly because he utilized Inuit and Siberian knowledge, including dog sleds and clothing styles. Scott brought ponies to pull sledges. Inuit technology was a lot better than British for the Antarctic. Anyway, the second evolutionary perspective suggests that in any reasonably large groups of human, such as groups of populations in a geographic area, which is the biological definition of race or subspecies, you will find the full range of human adaptation. This doesn't mean that everyone is identical in intellectual ability, but in any reasonably large group of humans, the average is going to be about the same as any other group, because natural selection on humans selects for our using our brains to adapt to our environments. And it would be very, very unlikely that the average from group to group is going to differ by very much. If so, those groups aren't going to be around. They will be selected against. I personally think that this perspective is a whole lot better supported by science, by observation, not by experiment. We haven't run any experiments. I don't think we should. But note that you can take a baby from anywhere. I mean, there are many, many examples of Russian babies and Korean babies and Chinese babies and African babies being brought to the United States as adopted. They grow up as American kids. They grow up speaking English or Spanish or whatever language the parents speak. They listen to the Beatles. I guess you don't listen to the Beatles anymore. They listen to American rock and roll, and they are American kids. There's a wonderful example of this, actually, with in the Voyage of the Beagle. Captain Fitzroy, on a previous trip on the around South America, had picked up 4 Tierra del Fuegans and brought them back to England with the plan of teaching them English, making little Englishmen out of them, and then sending them back to Tierra del Fuego to missionize the savages, as it were, as he referred to them. This was one of them died of smallpox, unfortunately, but the 3 that did survive did learn English. They wore English clothes. They ate with utensils. They even were entertained by the Queen. They adapted remarkably well to English culture. And of course, when dropped off back home, they ran off to their homes and picked up their old ways. Human beings are very malleable when it comes to central nervous system activities. They are very good at using their brains, using their communication ability and so forth, because it's our basic adaptation. And those characteristics are going to be canalized. Finally, we can't leave the idea that evolution is racist without visiting the role of evolution in natural selection and eugenics. Natural selection was enthusiastically embraced by Darwin's contemporary, Herbert Spencer. He applied natural selection reasoning to the analysis of society, what became known as social Darwinism. He's the one who coined that phrase, survival of the fittest, not Darwin. Spencer believed that the poor were poor because they were less fit. And it was a bad idea to help the poor or the infirm too much because, and I quote, pervading all nature, we may see at work a stern discipline, which is a little cruel, that it may be very kind. Nature would pick off the unsuccessful. We shouldn't stand in its way. These views were very popular among laissez-faire capitalists of the early 20th century. They were revived in Ayn Rand objectivism and, by extension, American libertarianism. Now I'll get mean email from libertarians. Andrew Carnegie and other laissez-faire capitalists justified sweatshops, child labor, exploitation of workers as being part of the natural and therefore natural selective order. As Carnegie said, and while the law of competition may sometimes be hard for the individual, it is best for the race because it ensures the survival of the fittest. Eugenics was also encouraged by Spencer's writings, but the father of eugenics was Darwin's cousin, Francis Galton. Galton is one of the most interesting people of the 19th century. He was a brilliant mathematician and general all-around original thinker. He read his cousin's book on the origin of species and was inspired to develop ideas about the betterment of human species through selective breeding of the more fit, what came to be called positive eugenics. Galton was applying natural selection ideas, but compared to some of the people who came after him, his views were comparatively benign. Much of Galton's writing encouraged the superior individuals to marry one another and reproduce. He had less concern with negative eugenics of preventing the unfit to reproduce, as you found in many of the laissez-faire capitalists. Now, eugenics is unquestionably a black mark in European and American history. Terrible things were done in its name. The sterilization of minorities, for example, and the so-called mentally defective. Lots of blame to go around. People like Teddy Roosevelt, Woodrow Wilson, David Starr Jordan in England, Winston Churchill, H.G. Wells, Maynard Keynes, George Bernard Shaw. Most of the intellectuals of the late 19th and early 20th century were caught up in this enthusiasm. The idea was the bettering of the species and reducing poverty, illness, and other miseries of humankind. However benign the intention and however much they thought that they would be improving the lot of the poor and the sick and the weak, etc., things didn't turn out quite as well as intended. And I assume you're all a bit familiar with the history of eugenics. It's a pretty dreadful history. Ironically, as the eugenics movement came to the United States, the churches embraced it, especially those promoting social welfare. Again, this was for the good of people. You know, a lot of these early eugenicists really thought that they were helping people. This changed a bit under the Nazis, but that's a sequel. The Methodist churches around the country promoted the American Eugenics Society Fitter Family Contests, wherein the fittest families were invariably fair-skinned and well-off. Methodist bishops endorsed one of the first books circulated to the U.S. churches promoting eugenics. Both conservative and progressive church leaders endorsed eugenics. The Methodists have apologized, probably others have as well. William Jennings Bryan is famous for prosecuting John Scopes in 1925, and the caricature is that he was a Bible-thumping fundamentalist, but he really wasn't as religiously conservative as portrayed, and his social views were extremely modern. He was against sweatshops. He was against child labor. He worked very hard to improve the conditions for the working person. And he was a strong opponent of laissez-faire capitalism in many respects, except for the creationism part. He'd probably fit in pretty well in Berkeley. And of course, he opposed eugenics. One of the reasons why he opposed evolution was because evolution was tied to eugenics by people like Spencer and people like Bryan, who really were very concerned about the welfare of the downtrodden worker, et cetera, were obviously going to be against evolution if that's the thing it resulted in. But many scientists during the heyday of eugenics vigorously opposed it as a misapplication of evolutionary ideas, including Thomas Henry Huxley, scientist and, we might note as humanist, freethinker. As I mentioned, Huxley was not as keen on natural selection as he was on the idea of common ancestry. But many scientists during the late 18th century felt the same way. They felt that there were many problems with natural selection as a scientific idea, although the idea of common ancestry was adopted relatively quickly. With the discovery of Mendelian genetics in the 20th century, those problems have been laid to rest. Accordingly, if there had been support from science, it would have withered quickly, as the genetically based theory of evolution and natural selection removed any shred of support from a scientific standpoint. There still are eugenicists and racists, but their views can no longer be supported by science, if ever they could have been. Still, you will find that anti-evolutionists and people unaware of history use an outdated 150-year-old connection between evolution and eugenics to discredit evolution, and their views have been accepted by many. I've already gone on too long already, but there's one more misunderstanding I'd like to deal with, and it's in this third category of patterns of evolution, and it's very widespread. This is the idea that fish evolved into amphibians, which evolved into reptiles, which evolved into mammals, and somehow birds are there someplace, but birds are warm-blooded, so they're like mammals, but they're really different from mammals, so we don't really quite know what to do with birds. But anyway, fish to amphibian to reptile to mammal is something that is really what a lot of people conceptualize vertebrate evolution as. Not what happened, guys. The history of vertebrates is actually a whole lot more interesting. Now, this diagram is going to drive everybody nuts, but stick with me, because I hope you will find it kind of fun, and I hope it'll give you a different perspective on our evolution and the evolution of creatures like us. And it will end up kind of reinforcing a point that I've been making throughout this talk. So here's the history of life, or at least our branch of it. Way back in the Precambrian, 500 million years ago or more, there existed a worm-like creature that differed in significant ways from creatures around them. Their left side was the same as their right side. They were bilaterally symmetrical. This was a new innovation. This lineage of animals split into two major groups that differed in a very small, but it turns out to be embryologically a very profound way. The protostomes had blastopores that developed into mouths, and the deuterostomes had blastopores that developed into an anus. There will not be a quiz later on what the difference between protostomes and deuterostomes are. Never mind. Protostomes gave rise to arthropods and their relatives, and segmented worms, and their relatives. Flatworms too, but they're cousins. They're not on the diagram. Deuterostomes gave rise to chordates and their relatives. Chordates gave rise to vertebrates, which split into two basic types, fish and tetrapods. And yeah, if there's an ichthyologist in the audience, they just fell off their chair and they're pounding the table with their fists because I am really lumping with fish, but deal with it. Obviously, there's a whole lot more to fish than that, but tetrapods are the ones I'm going to talk about. Tetrapods, Greek for four legs, are the varmints that moved onto land. And so they're the ones that are most closely related to us. Tetrapods gave rise to amphibians and amniotes. Amniotes are creatures with an amniotic egg. Amniotes include reptiles and mammals, both of which have amniotic eggs, and birds are an offshoot of reptiles, and of course, therefore, also amniotes. So it's not true that amphibians evolved into reptiles, evolved into mammals. The real sequence is tetrapods evolved into amniotes. Amniotes split into reptiles, including birds, and mammals. Takeaway. Evolution is the branching and splitting of lineages through time. I've said that before, but now you can really see it if you hadn't picked it up before. All right, lots more to say about misunderstandings of evolution, but you've all been very patient so far. Many thanks for having spent an afternoon with me. I'll stop here, and if there are any questions, I will try to answer them. And isn't that a fun cartoon?
Thank you so much, Dr. Scott. So please raise your hand so we can call people in order. So far, questions and comments from Craig, Larry, Mike, and Jeremy. But I have a few questions. Because you have been engaging in this advocacy work for decades. You've heard so many interesting points. And from people who may not have had a firm science education, it may be understandable. But from those who have studied biology, and especially for those in power who should otherwise know better, what are some of the gems that you've heard that have just made you facepalm yourself with how ridiculous it is?
Well, there is the beloved man evolved for monkeys. Why are there still monkeys? I mean, you know, that is one that you have to sort of smile and you know, I mean, you don't educate people by insulting them. So no matter how nutty or unscientific a comment might be, like I say, you learn a lot about people's views of evolution with AM talk show radio. You just, you know, accept it for what it is and try to steer the person around to a slightly more accurate point of view. Yeah, I'm there are lots of good stories. Some of the there's lots of really horrifying stories too. One of these days I really should write a memoir, because there's so many crazy things that have happened in my tenure at NCSE. But you know, one that just comes to mind right now is I was talking with a college professor from, I think it was Ohio. This wasn't on talk radio. This is just, you know, we were conferring about something. And she was saying how, yeah, she had gone to a workshop for the local high school teachers. You know, a lot of times college professors will help out and do some enrichment activities with local high school teachers. What's the newest science? High school teachers don't have time to keep up with the latest science. That's, you know, they have so many things to do. So this was a nice enrichment activity. She enjoyed it. The teachers enjoyed it. And she was talking with the teachers on a, you know, at the lunch break or something like that. And she said something about how, well, there's some new ideas coming along in taxonomy. And they all said, oh, no, we don't teach taxonomy, they said. It's too much like evolution.
Well, speaking and speaking of researchers, you've been involved in the secular movement for a while, and perhaps you've heard these particular thoughts emerge where, and I'd love your perspective on this, because I've heard these particular thoughts, and I think, well, maybe, but probably not, in terms of how their thought is going. These thoughts where if someone is a biologist, if they subscribe to creationism in any particular way, they can't be a functioning biologist. For example, we see two people named Francis, Francisco Ayala and Francis Collins, who are both creationists, but they're biologists, prominent biologists. Like Francis Collins, for example, running the Human Genome Project. What are your thoughts on, if someone subscribes to creationism in any form, does that just discredit them as a biologist? Does that
Jason, what do you think? What do you think? His interest, Francis and Francisco. What do you think Francis believes about creation?
From my understanding, the whole idea that a God put everything into motion, and then evolution became part of the process.
Okay, so why would you call that creationism? Sounds to me that if he thinks that Neanderthals are our closest relatives and that we share their DNA and that we are descended from Australopithecine-like things, and that whole big tree of bilaterians is actually real, seems to me he's an evolutionist.
Thank you. And
no, seriously, you actually asked two questions. both of the examples you gave, both Francisco and Francis, are people of faith. They embrace religion. We as humanists don't. But they also are perfectly competent scientists. In fact, Francisco works, he is an evolutionary biologist. Francisco Ayala is an evolutionary biologist. His whole career has been in evolution. And I know many other people of faith who are also evolutionary biologists or geologists. They work in evolutionary sciences. You certainly can be a person of faith and be a perfectly competent scientist. You cannot be a biblical literalist, believing in a special creation that God poofed into existence all of the universe and living things.
Yeah,
and particularly over a 6-day period. You cannot be a biblical literalist and be a competent scientist. I'm sorry, it doesn't work. Too many conflicts with what we know about about the history of the universe. That doesn't mean you can't be a person of faith, because one thing that I have learned in my many, many years at NCSC and as a college professor dealing at the University of Kentucky with religious students is that there, even just within Christianity, there's a huge range of beliefs. And, even among evangelical Christians, if you go to the biologos.com, maybe it's .org website, biologos, BIOLOGOS. It is an evangelical Christian website that tries to promote a better understanding of faith in the scientific community. Francis Collins was one of the people who founded it many, many years ago. You will find that there's perfectly modern evolutionary biology being presented at that site.
yeah,
You also will find some of the ID people trying to sneak in, but they don't get anywhere because most of the people there are theistic evolutionists and they don't agree.
that's my assertion, that you can be a person of faith and also a great scientist, because the difference between science and religion is our peer-reviewed process. Our peer-reviewed process, where our religious devotion is to the null hypothesis rather than trying to prove that something happened. So, Craig has a question.
Yes. Thank you, Dr. Scott, for being so generous with your time.
My telephone rang once a number of years ago, and my uncle was visiting me, and he picked up the phone and he said, hello. And the person on the other side said, Dr. Scott, and he said, speaking. And that really confused him. I'm not fussy about titles. I'm perfectly happy to be Eugenie among my friends here in the San Diego Humanists.
Well, I'm not a doctor, but you can call me doctor.
I'll call you doctor.
My question is regarding the challenges of language and science communication. I think we would agree that evolution is a process. And when we use the verb evolve with a science-educated audience, we're using it as a verb that is a shorthand for a process. And the language problem is, in general usage, a verb implies agency. And so when a nature program narrates that the viceroy butterfly evolved to mimic the monarch butterfly, a person will equate the subject of the sentence as the agent. And in our usage, the term evolve would represent the output of a process. In fact, the agent was mutation. So when I'm in the field, I do a lot of species identification. If I'm with somebody who's sort of religious, I will never, ever say something evolved. I will go through the entire process. I will explain the mutation and how it was an advantage or a disadvantage. I will go through.
Yeah.
So I don't know what your feelings on that is, but I try to avoid saying something evolved, but it's everywhere you hear it in the nature programs. And I just kind of like, do people know what they're talking about?
Well, they do. The trouble is they're speaking in English, and English is a terrible language for talking about evolution, because English is constructed. You have a subject, a verb, and a completer, a predicate. And so if something happens there had to be, as you put it, an agent. There had to be a noun in there, right? So if you say evolution produces such and such, that's terrible, because evolution is not a force. I mean, it's not an agent. It's not doing something. It's just, I'm not sure if there's any other language that's any better about talking about evolution. But yeah, when I was teaching at the university level, I had to be very careful how I phrase things as well. And obviously, you must be brilliant, because you came to the same conclusion that I did.
It's just, I guess you just have to do things longhand. It just, to me, it frustrates me because I watch the programs and I hear that shorthand and I'm thinking it works for you and I, but who else does it work for?
Yeah, it's there are terms that I avoid. I never use the word theory. You might notice I went through this whole talk talking about evolution and natural selection, and I mentioned some other mechanisms and so forth. I never used the T word once, because it's much more important what people hear than what you say. And when I say theory, I've got something very specific in mind. When a member of the general public hears the word theory, they're thinking not an inferential explanation based upon tested hypotheses, et cetera, et cetera. They're thinking guess or hunch. They're thinking something very different from what I mean. And I sympathize with the producers of documentaries and so forth, because you can't walk through this very long exposition every time you're talking about something that happens in nature. So I don't have an easy solution. I don't have a solution at all.
Well, thank you.
We have Larry.
As a follow-up to what you were talking about concerning social Darwinism, this question is about sort of I'm asking about your personal views, okay, regarding compensation. And for example, when the British expanded through Australia following the first colony in 1788, and the first peoples, they were dispossessed of the land. And the following 100 years of racism, do you feel that with people under these circumstances should receive compensation?
I have a number of Australian friends. I know a little bit about their history. I don't know a tremendous amount about their history. And I think it would be presumptuous for me to tell the Australians what to do. Personally, I think that there are reparations that need to be made regarding the Native Australians. I don't know how that would be done, but certainly there has been a very long history of mistreatment. I think the New Zealanders have actually done a better job of dealing with the natives and the Maori. I think the Australians have a ways to go. But there are thoughtful people in Australia who are thinking about this and working on it. But I wish them luck.
Yeah. Okay.
So I wanted to highlight someone. We have one of our members who is always out in the community, and he is giving out social justice-based T-shirts. And Mike Lewis, could you tell us a little bit about your social justice-based T-shirt, specifically relating to something that came up in the discussion in the presentation today?
Hi, Jason. Dr. Scott. I'm sorry for being formal. Yeah, I'm a longtime member of the North San Diego County NAACP, and I give away T-shirts. I have for years and years, and generally my T-shirts are encouraging people to, not necessarily believe in deity, but I thought, what shirt could I make, to promote harmony among people? So I came up with a shirt, and it's been by far my most popular. But I have to preface this. I think, science has always been tainted by the inherent prejudice of the scientists in the first writing, from Homer and the Greeks and stuff. Their prejudices are in their writings, and only with modern science and DNA and stuff can we now illuminate for the first time our true history. But one question I would like to ask before I talk about my shirts, I speculate that we could say that 50,000 years ago, the standard model for humankind was black because there were no Caucasians, none. And the diversity among Africans, because perhaps they had traveled by 50,000 years ago, but there was more diversity among Africans, north, south, east, and west, the different climates and stuff, 50,000 years ago than there's probably diversity now among everybody else who's left and evolved. So can we say today that the standard model, like in the past, I would think scientists would say the standard model for humankind was white, like Santa Claus and Jesus and stuff. But now I think we can agree the standard model for humankind has always been black. And until fairly recent times, there were no whites. And then we know now in the future with modern transportation, there will be no whites in the future, unless there's total breakdown of intercontinental transportation, and then various groups are isolated. But anyway, a question, would you say we can agree that the standard model for humankind is black? It always has been. And another, being a member of the NAACP, almost everyone is religious, and they think that the birthplace of humankind is in the Garden of Eden in the Middle East. So I made a shirt that kind of subtly removes the birthplace of humankind from the Middle East to Africa, where it belongs, even though, there's no Garden of Eden. So anyway, my shirt has a large DNA symbol across the top, and it says in big letters, DNA Science Update, : and two short sentences under it. All humans are of African descent, racists included. The second sentence, there is no gene for race or basis for inequality. And then in great big letters under that, don't hate. Smaller letters, we are family, celebrate diversity. So I've given away probably 165 of these shirts to anybody, even during the COVID, when I'm out and about going to the grocery store or whatever, I keep a supply in my car. And if anybody comments, I've never had a bad comment. And people, Caucasian or of color, say, thank you for the message. And I tell them, if you would like to share it, I'd be glad to give you one. So this has been my most popular shirt. So people are ready for this information. But anyway, is the standard model, we're all black, aren't we?
Well, the humans, according to the best science that we have now, and it probably is going to stick around, but according to what we understand now, modern humans evolved in Africa. But humans were spread out around the planet, humanoid creatures. There were Homo erectus fossils in Asia and Southeast Asia and the Middle East and Europe. They were probably replaced / absorbed, incomplete speciation, all that, by populations coming out of Africa. I don't like the idea of the standard model, because that implies that anybody who does not look like that particular feature is somehow not as human as others. And I think as humanists, we have to be very careful with even inadvertently spreading the idea that some of us are more and some of us are less human. The thing is, humans 50 years ago did not look like humans today. They were roughly similar. They were bipedal. They had big brains, etc. But why focus on skin color? Why is that an important issue? 10,000 years ago, people in Great Britain, at least some people in Great Britain, according to some genetic data, were very dark-skinned with blue eyes. I wouldn't be surprised if some of the people living in northern Asia, the Denisovans, named, it's a cave up in northern, near Siberia, discovered by a man named Denis. So the Denisovans from that cave, I would not be surprised if they were lighter skinned. You know, the thing is, whatever human variation we have today, it's going to be different 1,000 years, 2,000 years in the future. It was different 1,000 years, 2,000, well, maybe 4,000 or 5,000 years in the past. One thing we know about human beings is that we are all interfertile and genes get swapped around, and natural selection, I'm sure, does still operate on Homo sapiens. And you know, we shouldn't expect a one shoe fits all.
Well, prior to populations moving from Africa, there was only one continent with humans on it. You know, at one point in time, the only humans were Africans.
Depends on your definition of human.
Well, proto-human, but diversity explains the difference between us, not genetics. You know, the leaving from a warm climate to a colder climate, from low elevation to high elevation, different diets and stuff. But anyway, thank you so much for your talk. It's just fantastic.
I appreciate the sentiments on your T-shirt. I'm glad people are responding the way we as humanists would like them to respond to an inclusive message.
Thank you so much, Mike. Right. Next up, we have Jeremy.
There's Jeremy.
Well, first of all, thank you, Dr. Scott, for being here and for a most in-depth presentation. And as a fellow academician, researcher, and professor of developmental social psychology, I'll be less formal. I'll call you by your name since we're colleagues. So Eugenie, recently, like as soon as last night, Elon Musk said that he has autism. And in your opinion, do you think it's possible that autism is a form of neurological natural selection? And I asked that question about your opinion because my research is focused on special needs people, and in particular, how autistic individuals interact and cope with society, and in some cases are more successful in that they have the ability to focus their attention so directly and not let the emotions distract them from their objective. So at times I believe that autism is almost natural selection, because in some ways they seem like higher life forms. And I say that because I've dealt with like 5th and 6th graders who can do math, calculus in their head in front of me. And I'll ask them, well, how did you get there? And they're like, I don't know, I just see the numbers. And I'm looking at them going, whoa. How are you doing this? So, what do you think about it? Could autism be part of natural selection?
I'm not an expert on autism. My understanding is that it's a spectrum, it's a continuum.
Yes.
The kind of people you're talking about are at one end of the continuum. There are also people at the other end of the continuum who are not functioning well at all.
Yes.
And are very unlikely to pass on their genes. If you're talking about natural selection, what you're talking about is differential reproduction. So what is the offspring count, shall we say, of the Elon Musks of the world? If they're not passing on their genes, they're not, forget it. They're not being selected for. They're being selected against.
Well, and I think what you're saying has a lot of validity, because what I've noticed is that it doesn't seem to be as much a genetic component as it does to be an environmental factor, because I personally believe, and I can't prove it, but that being exposed to heavy metals and other things that the body doesn't know how to process are transferred in utero between parent and child. And we see that more and more frequently with pesticides and other things in our environment. Whereas genetically, like you said, it doesn't seem that people who have autism reproduce the next level of higher functioning Asperger. It just kind of seems to end at that person.
Yeah, it's like I say, I'm not an expert on that topic. I will defer to people who are.
Very good. Thank you so much. And Jason, who's next?
Right. Matthew is up next, followed by Esther, Arvind, Zem, and then any final questions because we're coming up on 3 o'clock.
Hello. Thank you so much for the presentation. It was really, really good. And I especially like it because I'm like a firm believer in evolution, and I'm pretty much mostly agnostic, but also mostly an atheist, and I don't believe in religion whatsoever. So I really appreciate the science behind the presentation. So I just wanted to ask though about I believe it was neogenics or the eugenics. I think you were talking about eugenics at one point, right?
I'm sorry, I didn't. You were moving around. I didn't quite hear the last few sentences.
Oh, were you talking about eugenics at some point in time?
Yes, I was.
Okay, so I was just wondering. So there's been a lot of points in history. I think especially during World War II where there was science that was that it was supposedly science by the people who did it, but it wasn't really done in a scientific way. They just called it science because they were doing it under the orders of someone who was in greater power than themselves. But there wasn't really any ethics to it. Like, for example, if you look at Joseph Mengele, he thought he was doing scientific experiments, but they weren't really scientific because he was just doing stuff for kind of really dumb reasons. So he called it science, but it wasn't really done properly. So it wasn't really science at all. He was just doing it to because he had the power to do it. So I was just wondering how those types of things, including eugenics, have impacted the ethics of science. Has it at all changed the way that science is analyzed, or the way it's spectated, or is there any more and because of that, is there any regulations for science that has to follow some certain requirements or anything like that?
Okay, you're dealing with a number of issues at the same time. You're dealing with science, how science is done, who does science, and the ethical context in which scientific research is carried out, if I hear you correctly.
Mm-hmm.
You know, the Germans were way ahead of the United States in discovering that cigarettes were really injurious to your health. They had done research showing that nicotine was addictive and that cigarette smoke was very bad for lung disease, possibly even heart disease. I'm not sure. We ignored all that because we assumed that the German science was crappy and not acceptable. We had to do all the work all over again to discover, to the detriment of those people who kept smoking for 40 years. That really cigarettes were very bad for you.
Mm-hmm.
There's a wonderful comic singer, Tom Lear, L-E-H-R-E-R. Raise your hand if you know who Tom Lear is. I mean, there's yay. Okay, some of us older timers, yeah, and young timers, good. Okay, Tom Lear has this. He has the line in one of his songs where he is mimicking Werner von Braun. And he says, and I will try to fake a German accent. It'll be awful and you just ignore me. Wenn the Rackets are up, who cares where they come down? That's not my department, says Werner von Braun. Idea being that some people think science can be done in a vacuum of ethics. And of course, it can't. It can. Goodness knows the German experimentations on the reproductive system, which turned out to, they discovered some very fascinating things about human reproduction, but they experimented on Jewish women and it was wholly, totally unethical. You can do science outside of an ethical standpoint, but you shouldn't. Science is a series of procedures for coming up with answers to questions about the natural world. It involves testing of claims about the natural world against the natural world, and rejecting the claims that don't pass the tests. I don't use the word experiment. It's sort of like the word theory. People have a different understanding of what experiment means. So an experiment is a test. There are a lot of different ways of testing explanations. That said, science has, I think, scientists have changed a lot of their ideas about the context in which science should be performed. And even if science per se technically doesn't have ethics involved with it, we don't worry whether it's ethical if coyotes eat chickens or coyotes kill sheep or your house cat. Science itself is not an ethical system, but the people who practice science, who perform science, should have an ethical system. And there are people who think about, the philosophers of science who think about the ethics of scientific practices and the ethics of the kinds of problems that are chosen by scientists to study and the way that they study these, like, don't do experiments on prisoners because prisoners do not have agency to refuse. I mean, there are a number of things like that that scientists and philosophers of science and ethicists and religious people have suggested as guides for how science should be done. So I think scientists need to be aware of that. They need to be aware of some of this literature, and they need to think about the studies that they do. And when I was a graduate student, which was back in the 1970s, yes, I'm very old, there were a number of things that would have been considered perfectly reasonable for scientists to do in terms of human experimentation. Quote, experimentation doesn't necessarily mean what the Nazis did, but giving a questionnaire to a group of people, or asking a group of students to perform some activity in a laboratory setting, which would be considered perfectly normal back in the 60s or 70s, but which today would be considered unethical because you are in some way because the person who is involved in the subject of that experimentation, the person that you are working with as a scientist, is not fully informed of any possible harm that might come to him or her, etc. So, I think things have gotten way better since 1945, but they have also improved even in the last 10, 20 years. So there's a ways to go. Ethics are generally not part of the training of scientists today, I don't think, but then I'm not training scientists. So I'm happy to be, and Jeremy, correct me if your graduate students do get a good dose of ethics along with their experimental procedures. So
we do give them a fairly heavy dosage of that, but whether or not they actually deal with that and adhere to it,
you never know something like that. I'm sure a minister or priest has the same reaction. Is any of this sticking?
So we have just a couple more questions as we wrap up. And I have to say, along with the song Werner von Braun from Tom Lehrer, something even more prescient about today's socioeconomic and political environment. Do you remember the last line in that song? In German and English, I know how to count down.
And I'm learning Chinese, says Werner von
Braun. All right, Esther, your question.
Okay, here I am. So it was interesting that you brought up the sandhills, because I live in Nebraska, and in very small sandhills towns is where I grew up. And I also thought it kind of brought up some questions about like, just for an example, I noticed a lot of my friends, their children will be bringing home homework in their science class that is biblically related, in which they teach right along with creationism, sort of. So they teach creationism right along with in their science classes. And then the other thing is that a lot of the population in some of these small towns still believe in eugenics. So, like, for example, I was sitting down with an old lady from church once, and she was talking about this family who had adopted a child, and it was kind of acting out a little bit. And she said, "Oh, well, you know, it all comes down to genes, don't you think?" And and so my question to that is, how can what are, you know, just some like basic strategies that, you know, a normal person can employ to ensure that some of these small towns actually get science-based curriculum?
Well, if any teacher is promoting creationism in the classroom, that has been judged unconstitutional by the Supreme Court. It's unconstitutional by the First Amendment, but the Supreme Court has validated that. And so it would be certainly possible for anybody, well, any person with standing in that community could bring suit. The first thing to do would be to find out what actually is going on. Students sometimes bring home distorted impressions of what's going on. They hear this, they pass on. It's like a, you know, game of telephone. And by the time it gets to the parent, it's something that's, you know, that needs to be double checked. So, you know, do your own fact checking, find out for sure what's actually going on in the classroom. And if a teacher is bringing in creationist materials or promoting the idea that everything was specially created as presented in the Bible, the first thing to do is to talk to the teacher and point out to the teacher that could be very offensive to some students' religious views, because not everybody agrees with that kind of Christianity. I'm assuming that they're all Christians, because that's very likely the case. Some of the most successful church and state separation cases actually have been brought by religious people, because what was going on in that community was a different flavor of Christianity than theirs. And so they were, you know, very easily able to make the point that this was an establishment of religion issue that should not be taking place. You know, appeal to patriotism. You know, the First Amendment gives us the right to practice any kind of religion we want, or not practice religion at all if we don't want to. But what that means is that schools have to be religiously neutral. We can't be promoting a particular religious view in the school, because that's really against American values. You know, you have to put it in terms of something that they will find an acceptable idea.
Right.
And then if the teacher refuses to change, then you go to the principal and you say, you know, Mr. Brown, this is Mrs. Baker has been bringing religious stuff into the classroom, and man, that's really serious, because somebody might bring a lawsuit and you're going to lose, because, you know, every single lawsuit that's been brought of a teacher bringing creationism to the classroom, they have lost, and it costs the district so much money. You know, maybe you ought to have a conversation with her just to sort of, you know, just teach the curriculum, just teach what the standards say, just teach what the district has told her to teach, and don't bring in this extra stuff, because, you know, man, that could really be expensive, because it's so expensive to go to court. Right. You have to appeal to what the principal is interested in. And if the principal brushes it under the rug, then you go to the superintendent and say, Mr. Johnson, you got a problem, because you've got a principal and a teacher who's going to cost your district a whole lot of money if somebody brings a lawsuit.
Right.
And that's generally the person who gets the attention. But of course, you know, this is the beauty of American education. It's highly decentralized and very varied. Some principals, some superintendents are elected. Some superintendents are appointed by the Board of Education. You need to know what the structure of education is in your community. This is why you have an organization like NCSE, because we've sort of thought this through for you already. You may want to, you know, if the superintendent wimps out, then you go to the chairman of the Board of Education, because that's the boss of the superintendent. That's a very long answer to your question about what do you do.
No, it was actually very informative. I don't have children myself, but it's just a question I had for other parents who, you know, who I've seen dealing with this issue.
Yeah.
So, because I mean, we're talking about small communities and under the population of 200. So the communities very much support what the teacher is doing. So
yeah. In that case, you're screwed. I mean, they're quite honestly.
Yeah.
There's not a lot you can do. You know, if everybody is on your side, is on the side of, you know, if nobody's going to complain, you can't bring a legal case. I mean, I'm talking about bringing legal cases. NCSE does not bring legal cases. I mean, we avoid as much as we can any kind of legal activity, because it is expensive, it is time consuming, it is exhausting. We don't have the resources to do that. On a couple of occasions, on several occasions, I have advised legal teams. And of course, NCSE was very much involved in the Kitzmiller versus Dover intelligent design trial. But, you know, we don't bring suit. It has to be somebody in the community who has legal standing to do so. But it's an absolutely last resort. You really want to solve these problems behind the scenes, solve these problems by just getting the teacher to change his or her behavior, because that's really,
Right.
you know, when the classroom door is shut, nobody really knows what goes on.
Right.
And what the teacher, you know, a teacher who's bringing in religiously oriented materials may be doing so because he or she feels that's the expectation. If a parent were to go and say, you know, I really would like you to be neutral about religion, because, you know, it's what the Constitution says we should do. And besides, it's not in the curriculum. And I know you've got so much to teach already that this is probably taking, you know, time away from stuff that the students might be better off spending more time on. You know, in general, when you're trying to persuade, you go to where the person is and you try to bring them to where you want them to be. And the best way of doing that is starting off with something you agree upon, and then you can, and you all agree upon that the Constitution is really important. We're all Americans, all that kind of stuff.
All right. Thank you.
You haven't seen any of those cute little deer mice, have you?
All the time. They run across the road and they really are that fat.
I gotta say the pictures that they had must have been some cage reared ones, because boy, they sure look pudgy.
All right.
They get quite large as well.
Thank you so much, Esther. So we're going to end the questions A to Z. Arvind to Zem.
Thanks, Jason. Ma'am, this was a really beautiful presentation. I just wanted to felicitate you. I really had a good time, I must say, and it was intellectually challenging to engage with your content, and you peppered it with humor and real life examples. Really, it was unbelievable for me. Thank you so much. My question is two-for. One is very quickly, we have seen the evolution of the human brain. There's some reports that the human brain has shrunk 40% over the last so many thousand years. And the size of the human brain has shrunk 40% is what I read in some studies. I don't know if it's 40% or 10 or 20%, whatever. The human brain is shrinking, and I read somewhere that it's because we no longer locomote and make those kind of physical decisions, and that's what the brain used to be so big for. And I also read an interesting article that says that with the digitization, digital world coming in, our brain is again kind of evolving in the sense it's morphing. The shape of the brain is like changing. I don't know if this is right forum to ask this question, but I wanted to know your thoughts on that. Where do you see the evolution of the human brain, especially coming from and going in the future? And Craig had a really interesting question. I just wanted to pitch that to you. You can take either of these, or just choose to answer either one or not. Craig's question is that with autistic people, is there an attraction between themselves that favors non-random mating? So, the gene pool becomes smaller because they're not mating with outside of their autistic gene pool. Thanks.
Yeah, your first question, I would doubt that that brains on average are getting smaller. Neanderthals on average had larger brains than we did, but that is unimportant. The range of size of human brains is enormous. Perfectly well-functioning human beings can have cranial capacities in the upper 900s cubic centimeters, all the way up to 17 and 1800 cubic centimeters. I mean, the range of normal human brains is huge. I really don't believe I've seen anything persuasive that on average modern human brains are smaller than those of human beings in the past. I would not expect brains to get smaller because we were moving around less. And who is we? People of Western industrial societies who spend a lot of time in chairs are not people like a lot of the people around this on this call are not necessarily representative of the species as a whole. You have to think cross-culturally. Even within modern Western societies, there are plenty of people who are physically active, people who are in construction, people who are in many service economies, agricultural workers. There are a lot of people who move around a whole lot. So we shouldn't just take one segment of the society as typical of a society as whole. We should not take a society like Americans or Europeans as typical of the species as a whole. There are plenty of people around the planet who are working very hard and have very physically active lives. I don't think their brains are larger or smaller than us. So I don't think physical activity and brain size is going to be very reliably related to one another. In the future, I don't think that we're likely to see brains getting smaller or larger. I think the majority of natural selection on human beings today is probably going to be biochemical rather than physical biological in the sense of taller, shorter, fatter, thinner, et cetera. And it's been brought up a couple of times in this, in various questions, genes versus environment. Well, most of the characteristics that we observe, how tall you are, even how dark your skin is, how light your skin is, your weight, your intelligence, your ability to read, do math, etc. Those are all what biologists would call phenotypes. And all phenotypes are a mixture of genes plus environment. Jeremy was talking about autistic people that he has worked with, where he believes that there is not just a genetic component, but also an environmental component, and it may be prenatal. Oh, okay. Absolutely. Those are environment, and the phenotype of autism is a result of genes plus environment. And for any particular individual, it would be hard to tease out whether the genes or the environment is more important, but it's even harder as a group to tease out those kinds of characteristics. So I would tend to be I would tend to be very careful about making assumptions about future human evolution. In terms of natural selection, remember my little diagram there showed that a very important component of evolution is not just, excuse me, an important component of natural selection is not just the genetic variation in a population, but also what kind of environmental pressures act upon that variation. And unless we can predict our environment of the future, we won't be able to say what traits are going to be selected for. And I don't think we have a very good idea of what our future is going to be. Anyway, that's my opinion.
Oh, thank you so much, ma'am. Thank you so much.
Zem.
Zem, you're up.
Yeah, Dr. Scott, thank you so much. Brilliant presentation. I have a simple question. Do you think that at some point in the future, we will all be the same race?
No.
No, never?
Depends on what you mean by race.
Well, all of the characteristics that you've described and the different adaptations that Homo sapiens has gone through based on the geographical location that they were living in, you know, the accounting for humidity, for example, that you mentioned. Mm-hmm. Do you think those, you know, due to our, well, not complete, but improving control of technology, control of the environment, as well as the fact that we're really globalized, we can go anywhere now. And any race of people can move halfway around the world in 12 hours. You know, well, that's what I was thinking of, you know, that eventually, you know, the whole world will basically integrate into a single, you know, a singly adapted version of us, of all the races.
I think what you're talking about is the potential of great movements. But if you're going to move from Siberia to San Diego, you're going to have to get some sort of conveyance to get there, which is going to cost money, which means probably most Siberians are not going to be moving to San Diego or vice versa. The kind of mixing of populations that you're talking about is theoretically possible, but I think highly unlikely from a practical standpoint, because we don't have that many ships and airplanes to move 8 billion people around to all of the various continents of the world and just mix everybody up. If we do, then we might get much more homogeneity of appearance. And that kind of tends to be what people think of when they think of race, unfortunately. They think of appearance. They don't think of characteristics that are invisible, which may be selected for even more so. Some of the really interesting human adaptations are things like high heat and high altitude, which are generally speaking invisible characteristics of, you know, like a high hemoglobin count in Andean Indians, for example. Anyway, I think natural selection will continue to act. It is reduced in some respects, but there's natural selection going on right now during this pandemic. Right? Immune systems. You know, the species is not homogeneous and has never been and is highly unlikely to be so in the future.
Thank you so much.
Well, can everyone please unmute themselves and give Jeannie a warm San Diego thank you. And Jeannie, once we are able to meet back in person and have larger events again, you are cordially invited to come and join us and share your wisdom with us. Thank you so much for being here. And like I said, the theme of today was interdependence and being interconnected. And I think that you've demonstrated beyond the shadow of a reasonable doubt that we're truly all interconnected. Thank you so much for being here.
Well, you are more than welcome, and I enjoyed my time with you. Thank you for inviting me.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Bye-bye now.